I really like teaching this polynomial lesson because it's very much just pattern finding. And once you get the hang of the pattern, you're pretty much good to go. I do have to get through all of this information about polynomials first, though, so let's go ahead and get through that. So polynomial characteristics. It is a smooth curve and it's continuous. So what that means is there's no breaks, there's no asymptotes, there's no sharp edges like a absolute value, like you don't get a point there. Basically no emotional problems, like it's just good to go. All polynomials are like that. It's a nice smooth curve with no holes in it or gaps or breaks or anything else of the kind there. So they're nice. An even degree means the ends go the same direction. So they're either both up or both down if you have an even degree. And the degree is the highest power. That's kind of like who's in charge here. So whatever the highest power is, that's the degree. Ends go the same direction. If it's an odd degree, the ends go opposite directions. And so again, that works out just as far as like the English language is odd, opposite. So even degree ends go the same way, odd degree ends go opposite ways. All right, the least possible degree is the number of turning points plus 1. So for example, if there are 7 turning points, the least possible degree would be 8. The degree could be 9, 10, 11, 12, 13, or 4 billion, you know, but the least possible degree is 1 more. So you take the turning points and add 1. So what I'm saying there is if there were 7 turning points, the degree couldn't be 6. It couldn't be lower than that. It has to be like plus 1 or more. If your leading coefficient, and that's your coefficient that's with that degree term, if it's written jumbled up, it might not always be the first term, but it's whatever's with that highest power. If your leading coefficient is positive, the right side goes up. And if your leading coefficient is negative, your right side goes down. Now, what makes this a little tough is when you graph these, we have to go right to left, which I get is backwards. Everything else we do is left to right. Well, we don't know what the left side is doing. We only know what the right side is doing. So you will have to graph them right to left, which is, you know, you'll be okay, all right? So we're going to answer some questions about these using this graph right here. Is the degree even or odd? You want to look at the ends. They're going the same way. So what do you think? Even. Good. That's really all there is to that. What is the least possible degree? Are you going to add up the turning points and then plus 1? So here are the turning points. Ready? Here, 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 and here. So what do you guys think? 6. There's 5 turning points, so the least possible degree is 6. So this happens all the time. People will say the degree is even and then put 7 there. And that blows my mind. If you say that it's even, you should put an even number there, right? Or like if it's odd, like work with me, make sure that they match, right? Is the leading coefficient positive or negative? Well, the right side is going down, so negative. And when we go to graph these, you're going to look at the multiplicity, which means the power. It's going to be the exponent on the factor. You have a multiplicity of 1. It is just going to cross the x-axis. Like a line, a power of 1 means linear. So it's just going to go straight through. A multiplicity of 2, we say that bounces at the x-axis, which means it acts like a parabola. To the second power squared means it's going to look like a parabola. We just call it a bounce just to, you know, call it something. And then does anyone remember what the power of 3 is going to do? Wiggle. We call it wiggle just, you know, for the sake of calling it something, but it's going to wiggle at the x-axis, which to the third power means cubic graph. So they all make sense, right? 1, 2, 3. So again, it's just about pattern finding. And you just have to practice a few of them. So like, I'm going to do one and you might be like, sort of remember that. Then I'll do the second one and you'll be like, oh, I kind of get it better now. And by the time I do like the third and fourth one, you're going to be like, oh, okay, got it. Like you just have to see a few of them. So looking at this first one, values I can put on the x-axis would be 4, because 4 minus 4 is 0, and 1, because 1 minus 1 is 0. Now, please listen, if you're a perfectionist, this may bother you a little bit. Those are the only 2 points we're plotting specifically. The rest of it is like, good enough. You're going to have to just accept that. I know some of you are like real type A and you want it to be perfect. It's not going to be perfect. So just take a deep breath. It's going to be all right. Now, is the right side going up or down? Well, I don't see a negative out front, so it's going to be going up. And I just always put a little arrow up or down to remind myself. And now you basically play connect the dots. You just have to go right to left and follow this pattern. Does it cross, does it bounce, or does it wiggle? All right, so look, when we get to 4, we're going to look at the factor with the 4 in it. What is the power on that one? Good, 2. So what are we going to do at the 4? Bounce. So when you get to that, make it look like a parabola. And then when we get to the 1, that comes from the factor with the 1. Now it's not written. What's the power on that one? 1. It's not written. It's understood to be a 1. So what are we going to do there? Just cross. It's going to go straight through like a line. And that is it. I kind of love these. It's like doodling in math class. The only uncomfortable part is you have to go right to left. All right, let's try another one. What are the 2 numbers I can put as zeros? Let's see, on my x-axis. Good, 2, because 2 minus 2 is 0, and then -3, because -3 plus 3 is 0. All right, what is the right side doing? Going down. We have a negative, so it's going down. Just put a little arrow to show you it's going down. And then we're going to play connect the dots. Bless you. So when I connect to the 2, again, that's the only uncomfortable thing. You have to go right to left. When I connect to the 2, that's going to come from the factor with the 2 in it. Just make sure you match them up because this might be written in whatever order. What's the power on that? 1. So we're going to cross straight through. And then when we connect to the -3, that comes from this factor with the x plus 3 in it, that's cubed. So we are going to wiggle. People have trouble drawing the wiggle sometimes. That's okay. Make an attempt to get it to bend. And then you can always just go like this, like just label it for me and I'm happy. Like if you make an attempt and then just label it, it's like when you're 3 and you draw a dog, but it looks like a potato. So you write dog and then everyone knows what it is. It's just like that. Okay. Yeah. Now, how far up does this go? No idea. How far up does this go? No idea. Without a calculator, I don't know. So it's just good enough. You guys try this one. All right, this one's a little tricky because the zeros that you're going to place on the x-axis are +3 and -3. So you got to be really careful with not getting them mixed up with each other. Does the right side go up or down? Down because of the negative. Now, when you connect to the +3, that comes from this factor. Does that make sense? 3 minus 3. Okay, so that's squared. We're going to bounce. And then at the other one, the -3 that comes from this factor, it's cubed, so we're going to wiggle. Did it go okay? Does your doodle look sort of like mine? Okay, all right, good deal. Now here, oh, yes, ma'am. Yeah, it's sort of just where it ends up, but that's a really good question because if you want to double check, if it's an even degree, they're going to go the same way. An odd degree, they're going to go opposite ways. So here's the way you can double check. Add up these exponents. So like if you look back at number 1, your exponents were 2 and 1. So that degree is 3. 3 is an odd number. So do you see how they're going opposite ways? Here, let's do that again. For number 2, the powers were 3 and 1. So what would that degree be? 4. 4 is even. So do you see how they're going the same way? And then I'm glad you asked that because that like tied that together so nice. All right, what is the degree for this one then? 5. Good. We have 2 and 3. So 2 plus 3 is 5. 5 is odd. So they should be going opposite ways. But yeah, when you start on the right, you kind of just do whatever the pattern tells you to, and the left side just ends up going whichever way, but you can check it that way. Now here we're going to do that backwards, which people tend to like better because they don't have to actually draw a graph. We're going to write the equation. So put f of x equals, we're going to again read it right to left because I think that if we just stay consistent with that, that'll be good. We're going to read it right to left and build the equation. Now for this one, the right side is going which way? Down, so you need a negative. If it's going up, just don't put a negative. All right, and again, I'm going to read it right to left just for consistency's sake. My first 0 is at 4, so I'm going to put x minus 4, and it is bouncing there, so the power will be 2. Sometimes people are like, there's too much going on in the graph. Remember, you can use your hands to cover it up. Hey, look, do you see how that little part looks like a parabola? Like just kind of zoom in on that point. You can always do that. All right, the next one is at 1, so I'm going to put x minus 1 is the factor. It's bouncing there again, so squared. And then the last one is negative 2, so x plus 2. It's just crossing there, so it would be to the first. You don't even need to put the 1, though. You can just not put anything. So let's try this one. What is the right side doing? Going up. So you just don't need a negative. Just don't put anything. You don't have to put a plus. Just don't put anything. And then our first 0 is at 3. So what will our factor be? At x minus 3 and 2 what power? 3. Good. It's wiggling there. So cubed. And then this one is at negative 4. So that'll be x plus 4. Also wiggling. So also cubed. And then last one, f of x equals, what do we need out front? Do we need a negative or no? If you do need a negative, so put a negative. All right, and then what's our first factor going to be? Good, x minus 4 to what power? The first, or you just don't have to put anything. This one's a little tricky. It's at the origin, so it would just be x. Like to put x minus 0, that's totally fine. Just x minus 0 is just x. And then what power will that have? Good, squared. And then for negative 2, we'll have x plus 2. And again, it's just crossing straight through, so to the first. All right, so the next thing we're going to get into is dividing polynomials. The first method, there's 2 ways to do this. The first method is synthetic division. The first one of these I do, you are going to be like, oh my gosh, I understood none of that. Okay. Then the second one, you're going to be like, oh, I kind of see what's going on. And then again, by the third and fourth one I do, you're going to catch on. It's actually very, very simple. And once we get through a few of these and you see it, people just start churning them out. They become little correct answer machines. Okay. Like you just have to watch. Okay. The first thing you're going to do is look at whatever you're dividing by and decide what makes that 0. So, hey guys, what makes this 0? 2. You are going to put 2 in a little box off to the side. Then what you're going to do is thief all the coefficients from the rest of the problem. You're just going to steal the coefficients. So do you see how we have 2, negative 6? This one would be what? 1, good, and then 5, and then negative 3. Here's the thing. I made the first one simple. They have to go in descending order for the powers. So do you see how this is to the 4th, and that's to the 3rd, and that's to the 2nd, and that's to the 1st, and then this is x to the nothing. You have to make sure they're in order, and if you're missing one, you put a 0 to indicate that you have none of them. But I always just tell everybody, I'm goofy about it to try and get everyone to remember. Make sure you do a countdown starting from the first power. And if you don't get down to 0, you have done goofed. Okay, ready? 4, 3, 2, 1, 0. We're good. okay? This next step, I want you to set your pencil down and literally just watch because it is so quick and easy, but if you look away, you will miss it. You're gonna draw a line. You're gonna bring down the first number. I have people that try to do this problem without bringing down the first number, and I'm like, what are you doing? There's nothing there. All right, you bring down the first number, and then it is multiply, add, multiply, add, multiply, add. I believe you can multiply, and I believe you can add. You're gonna be totally great at this, all right? 2 times 2 is 4. You're gonna add this column, -6 plus 4, -2. Then I'm gonna do it again. 2 times -2 is -4. We're going to add this column. That would be -3. Do it again. 2 times -3 is -6. Add this column. You get -1. And then one more time. 2 times -1 is -2. Add this column. You get -5. It is multiply, add, multiply, add. Again, if you're looking at me like, what was that? I told you it was going to be that way. Wait until we do a couple more. But go ahead and write that down, and then I'll show you how to write the answer. So whatever power you started with, this is x to the 4th, you're going to start with 1 less. That's because you divided out an x. You have x to the 4th, we divided out an x. So we're going to start with x to the 3rd, and it's going to go in descending order. So these are your new coefficients. It'll be 2x to the 3rd minus 2x squared minus 3x minus 1. And then this is the remainder. I'll show you how we tack that on at the end. But again, you start with 1 less than what you started with. It's going to go in descending order. We're going to tack the remainder on at the end. Now I realize it's a -5. No matter what sign that comes out to, I always put plus just for simplification. Like I just always make it positive. So it'll be plus -5, and you just put it over whatever you were dividing by, which in this case is x minus 2. You don't have to do any work with it. There's nothing else to be done with that. You just put it over whatever you were dividing by, and that is your answer. Go ahead. That's on the back page right here. I've got you. Now I'm going to go over the vocabulary. I'm not going to necessarily test you on this vocabulary, but I'll use the vocabulary while I'm talking about this stuff. So it is important for you to know. This thing is called the dividend. D-I-V-I-D-E-N-D. Sorry, I know my handwriting is a little loopy. Dividend. Whatever you're dividing by is called the divisor. So the dividend, the divisor. The result you get is called the quotient. And then this is the remainder. And again, I wouldn't put a question on a test about one of those vocabulary words, but I'm going to use them while I'm talking about these. And so it helps if you just, instead of going that thing, like if you have a word for it, it makes life a little bit easier. So let's try another one. Again, this is just a drill and practice thing. Once you get the hang of it, I'm not joking. You will be able to just churn these out because it's multiply, add, multiply, add. First thing, what number is going to go in the little box off to the side? It's whatever makes the divisor 0. So what will make this 0? Put -1 in a little box. Now you're going to thief all the coefficients from the problem. I did make us miss one here though, so that we have to put a 0 in. Do you see it? How one of them's missing? We have 3x to the 4th, but then there are no x to the 3rd. So you have to put a 0 there. It's indicating there are 0 of them. And then -2, and then 4, and then 8. Always check your countdown. I know it sounds silly, but we remember stuff that's silly. We're going to count down from 4. If we don't get to 0, we have a mistake, right? 4, 3, 2, 1, 0. We're good. If you want to, again, just watch me do this. Like, yeah, set your pencil down and just watch because it happens so fast, right? You bring the first number down. I'm going to ask you guys this time, though. We're going to multiply. What do we get? Good. Add that column. Good. Now we're just going to do it again. It's cyclic. You just keep doing the same thing over and over. -1 times -3. 3. Add the column. 1. Do it again. -1 times 1. -1. Add the column. 3. -1 times 3. -3. Add the column. This is it. Then you write out the answer. You start with the power 1 less than what you had originally. And again, it's because you divided out an x. So what power will we start with? Good. 3x to the third. And then it'll be minus 3x squared plus 1x plus 3. It's just going to descend. It's going to go in descending order. The remainder just gets tacked on at the end. It'll be plus 5 over the divisor, which was what? X plus 1. Awesome. I want you guys to try number 11 with your group, and then I'll go over it. Try number 11. Sorry. Try number 11, and then I'll go over it. Those ones have a little, there's one little thing that's different, but I want you guys to try one before I do. We're going to go back in one. But everybody just try number 11 real quick. All right, what did you put in the little box off to the side? Good, -3. And are we missing anything here? We're missing a squared. Okay, so it will be 1x to the 5th, 2x to the 4th, -2x cubed, 0x squared, and then -4x, and then -5. And if you count down from 5, 5, 4, 3, 2, 1, 0. So if you missed that 0, your first half of it was good. You just need to fix the second half. So bring down the first number. We're going to multiply, add. This will be -3. Add, you get -1. Multiply again, you get +3. Add, you get 1. Again, I'm going to keep the numbers little for you. Multiply again, you get -3. Add, you get -3, because that's 0. -3 times -3 will be 9. Add, you get 5. -3 times 5 will be -15. Add, you get -20. What power are we going to start with when we put the variables back in? 4. Good. So you have 1x to the 4th minus 1x to the 3rd plus 1x to the 2nd. A lot of ones there. Minus 3x plus 5. Again, it's just going to go in descending order. And then for the remainder, I always put plus. I think that's just easiest. You don't overcomplicate it. And then it's just that number over the divisor. Yes, go ahead. No, I just did that to show that these are the same. But yeah, what she's asking is do you have to put those there? No, you don't. All right, so let me go back and look at number 9. The only difference with this one is there's going to be a fraction, okay? What little number is going to go in the box off to the side? What would make this 0? 1/2, good. So put 1/2 in the little box. And then we're going to take all the numbers from the problem. Are we missing anything, or does it go in order? It goes in order, we're good. So 2, -5, 4, -1, 2, 7. I know some of you are nervous about that fraction. They will all cancel. I'm not going to make it end up being fractions in here. It's going to be okay, I promise. All right, so bring down the 2. We're going to multiply 1/2 of 2. 1, good. Add the column, -4. 1/2 of -4, -2. Add the column, 2. 1/2 of 2 is 1. Add the column is 0, which is kind of nice. 0 times 1/2 would be 0. Add the column, you get 2. 1/2 of 2 is 1. Your remainder is 8. Here's the only thing that you have to do before you write your answer for these ones. When you end up with a fraction, aside from the remainder. Never touch the remainder. That remainder is 8, all right? All the rest of these, you'll have to divide out that 2. So just divide them all by 2. You will get 1, -2, 1, 0, 1. Hey, but Ms. Cole, 8 also divides by 2. I know that's a coincidence. The remainder is just the remainder. Never touch that. All right, but you just have to like reduce those numbers. And then you're going to put the variables back in. What power are we going to start with? Good. 1x to the 4th minus 2x to the 3rd plus 1x squared plus no x's plus 1. Do you have to write this no x's? No, I put it there to show the pattern, but you could just put nothing. And then it's 8 over the divisor. For the sake of time here, because I do need to have time to get to the long division on the other side, let's just do one or the other of these. Which one looks scarier to you? 10 or 12? 10, okay. What number will go in the little box off to the side? Careful, not 1/3, but good, -1/3. All right, are we missing anything? Yeah, we're missing the x to the 1st, right? There's no plain old x's. So it's going to be 3, -5, 7, 0, -1. And again, you can check with your countdown. 4, 3, 2, 1, 0. Blast off. We're good. Again, I'm going to put that away, teaching. I'm going to make sure that all of the fractions cancel, right? So bring the 3 down. -1/3 times 3. Good, -1. Add the column, -6. All right, -1/3 times -6. Well, the negatives cancel. 1/3 of 6 is 2. Add the column, you get 9. Do you see how I orchestrated it so it's going to like divide by 3? Okay. -1/3 times 9 will be -3. Add, you get -3. And then -1/3 times -3 will be 1. Add, you get 0. The remainder came out to be 0. There is no remainder. Isn't that nice? You just don't have to write it. We're going to start with x to the 3rd. So 3x to the 3rd. Oh, whoops, I'm sorry. I forgot to reduce it. I'm sorry. You got to divide them all by 3. I'm sorry. I caught it though. Divide them all by 3. You will get 1, -2, 3, -1. Now this remainder came out to be 0, but you wouldn't touch that anyway. All right, so 1x to the 3rd minus 2x squared plus 3x minus 1. All right, so here is the long division. First, I'm going to review it with just numbers before we put the variables in there, but this process is the exact same. What grade do you do this in? It's got to be after 4th grade. Oh, really? Oh, because my son is in 4th grade right now, and they haven't gotten to it yet, but it's coming. So, okay. Okay. Well, here we go. Look. Does 3 go into 1? No. All right. So then get the next number. Does 3 go into 16? Yes. How many times? 5. Because 3 times 5 is 15. There we go. You're trying to get it as close as you can. 3 times 5 is 15. I feel like we're all still together. And then you're going to subtract. I'm going to say that again. And then you're going to subtract. Negative signs are the most commonly missed things. So subtraction is actually the tough part here. Okay. 16 minus 15 is 1. And then you bring down the next number. Again, it is cyclic. Then you just do it all over again. You get a shot at redemption here, guys. How many times does 3 go into 13? 4. 3 times 4 is 12. And then you're going to subtract. And then you're going to subtract. And why is she hammering this hard? Because I've done this. Do you know how many years I've done this? Because I know that that's the thing people miss is the subtraction, right? 13 minus 12 is 1. Bring down the next number. Do it again. 3 goes into 14. Good. 3 times 4 is 12. And then you're going to subtract. 14 minus 12. 2. Bring down the 5. This is the last one. 3 goes into 25. 8 times. 3 times 8 is 24, and then you're going to subtract, and you get 1. 1 is your remainder. Now, when you were in 4th grade, you just wrote R1. Do you remember that? Remainder 1. We would put the 1 over the divisor, but that's how this works, okay? So when you look at this, you're going to compare the first 2 terms. You want to turn an x into a 2x to the 4th. You want to turn an x into a 2x to the 4th. What would you have to multiply by to turn an x into a 2x to the 4th? 2x to the, good. 2x to the 3rd goes right there. And what you're going to do is distribute that into here. And it will all line up beautifully right here. They will all line up. If you distribute a 2x cubed into the divisor, that will give you 2x to the 4th minus 4x to the 3rd. And then you subtract. So you have to give it a hug and subtract the whole thing. Always the first column will cancel. If it doesn't, you had a mistake, because that's the idea, is you want the first column to cancel. 2x to the 4th minus 2x to the 4th is going to cancel. Here's the step that is commonly missed. You are subtracting a -4. So it's really what? It's really plus. And some people will erase that and change it to a plus. I'm not going to do that because I don't want to mess anybody up. But we are adding 4 here. -6 plus 4 is -2. -6 plus 4 is -2. Then we're going to bring down the next term, this x squared, and do it all over again. Oops, I forgot the plus though. Plus x squared. If you were like, hey, I didn't quite get that, don't worry, it's cyclic. We're going to do the same thing over and over and over and over again. So you will eventually get the hang of it, and then you just repeat the process. You're going to compare the first 2 terms, x with -2x cubed. What am I going to multiply by to turn this into this? -2x squared, good. You're going to distribute that -2x squared into that divisor. So that will give you -2x cubed plus 4x squared. Did you guys follow me there with the plus 4? -2 times -2? -2x squared times -2 will be plus 4x squared. And then you subtract. Give it a hug. Subtract the whole thing. What's going to happen to the first column? Cancels. It should be the same. They're going to cancel. And here's the step that's tricky. You have to subtract. So this is a 1x squared minus 4x squared. So what will that give us? 1 minus 4. Good. -3x squared. You're going to bring down the next term, the plus 5x. Do it all again. Compare the first 2 terms. I want to turn an x into a -3x squared. What will I have to multiply by? Good, -3x. Distribute that -3x into the x minus 2. That will give you -3x squared, and then what? Good, plus 6x. And then you subtract. What's going to happen in the first column? Cancels. Make sure you subtract. This is a -6. So 5 minus 6, -1x. Bring down the -3. We're going to do it one more time. It's always exciting when you get to the last time through. All right, we have an x. We want it to be a -1x. What would we multiply by? -1. Distribute the -1 through there. It'll be -1x. And then what? Plus 2. Good. Subtract. The first column is going to go away. And then just remember you're subtracting. The negative signs are the hard part, all right? This is -3 minus 2. So what's our remainder? -5. Good. I always add it. Just dealing with the negative is tough. So I just always put plus, and it'll be -5 over x minus 2. I made this the exact same problem as one that we already did so that you could compare and contrast it. It's this very first one that we did. So you can see it worked out both ways. I'm only going to have time to do one more. I will fill them all out so you can have it in your notes. Let's do this one though. Compare the first two terms. You have an x squared. You want it to be an x to the fourth. What are you going to multiply by? Good, x squared. Distribute the x squared through there. That'll give you x to the fourth plus 3x cubed plus 2x squared. And then you subtract. So what happens to the first column? It cancels. And then subtract the others. What are we going to get? Good, negative 3x cubed. And then this will be negative. Perfect, you got it. Bring down the next term, the negative 2x. We're going to do it again. Again, it's cyclic. You just do the same thing over and over. Compare the first terms. You have an x squared. You want it to be a negative 3x cubed. What do you multiply by? Negative 3x. Awesome. Distribute that through here. That will give you negative 3x cubed minus 9x squared minus 6x. And then you subtract. And so the first column cancels. Be careful with the negatives. This is negative 8 plus 9. Are you guys with me there? All right, so what goes here? Good, 1x squared. And then this is, again, you're minusing a negative 6, so it's plus 6. So this will be plus 4x. Bring down the negative 1. We're going to do it one more time. You have an x squared. You want it to be an x squared. I know that feels like you need to do nothing, but what do you multiply by? 1. So plus 1. Distribute the 1, which is great because it doesn't change. And then you subtract, and whatever's left will be the remainder. First column cancels, and then what's left? X minus, good, 3. Remember, you're subtracting the 2. So here's how you're going to write it. Plus, just add on your remainder, x minus 3 over whatever you were dividing by. The divisor, which is that x squared plus 3x plus 2. Last thing I'm going to say to wrap this up, I want to have you notice something, and I want to talk about how they do this on delta math real quick. This one we did with synthetic division. This one you could also do with synthetic division. In fact, I think I made that the same as one of the other questions on here. I don't remember which one it was. These two you cannot do with synthetic division. You're like, why on earth are we even learning the long division? Why won't these two work with synthetic division? Yeah, if you're dividing by a square, do you see what I'm saying? Like, what would go in the little box? So that's why this is necessary, okay? On delta math, their directions say use long division for every single one. I don't want you to do that. If you can use synthetic division, isn't this a lot easier? Do synthetic division. Only use long division if it's one like this, okay? Their directions are going to say to do it every time, but don't. Only do it if you have to. Okay. You have to do long division if you have a squared that you're dividing by, because there's no number that would go in the little box off to the side. But again, delta math is going to say do long division for every single one, but I don't want you to have to do that.